Technology advancements have been able to miniaturize laser while keeping the performance of the laser and allowed them to be used in a handheld format, which is the handheld LIBS you see today. In this podcast series, Masters of PMI, my goal is to help you be successful with positive material identification and truly master your metal testing wherever you may be in the metal supply chain. All the way from scrap metal recycling to metal production at foundries and mills, to parts fabrication and inspection, PMI testing plays an important role in making sure everyone knows which metal they are working with in order to avoid material mix-ups that can lead to unhappy customers, expensive recalls, or even catastrophic accidents like oil spills, plant explosions, and airplane crashes. I don't think we like those things, so let's get to it. Today we'll be talking about handheld LIBS and its use for positive material identification. I'm excited to cover this topic because there's a surprising amount of misinformation and confusion regarding this technology. It's only been out for about 7 years, and just like XRF, is perfectly capable of doing many PMI testing applications for metal identification. So let's start with what it is. LIBS stands for Laser-Induced Breakdown Spectroscopy. And it's actually in the same family as OES, or optical emission spectroscopy. It's just using a laser instead of a spark to basically burn and vaporize the metal and cause the elements of that material to give off a light signature. The detector and the analyzer uses those light signatures to determine the chemistry and makeup of the metal. Once it knows the percentages and the chemistry and the composition, just like the other techniques, it's matching it against a grade library to tell you what grade it is, like stainless steel 316 or aluminum 6061. LIBS has only been around for maybe 7 or 8 years in handheld form. The LIBS technology itself is fairly old, but it's been limited to use in the laboratory via benchtop instruments, for example. But recent technology advancements have been able to miniaturize laser while keeping the performance of the laser and allowed them to be used in a handheld format, which is the handheld LIBS you see today. Now, since it's a newer technology, just like anything new, it's gonna not be perfect at first. And when LIBS first came out, kind of a combination of factors that led to there's some distrust in the technology, people not understanding it to be as good as XRF or OES in doing certain applications, along with some maybe some overpromising that might have happened as to the capabilities of the technology. But fast forward to today, LIBS is a perfectly capable tool to do a lot of the things that XRF can do. So I want to go over the pros and cons of LIBS to really get an understanding of why you might consider using it as opposed to a handheld XRF. Now, some of the pros to LIBS or handheld LIBS, it's generally much faster. It's a much faster technology. They generally take about 1 to 3 seconds, which is much faster than the handheld XRF in most cases, especially older analyzers, which can take 5, 10, upwards of 20 seconds depending on the application you're working on or the metal that you're testing. So LIBS is generally much faster in that regard. Also, it's always going to take the same amount of time, so time is not a variable like it can be with some XRF analysis. You're always going to get the same time reading, so the amount of light that the instrument's seeing is not going to change because of how much time you're taking the test. Another pro, especially in comparison to handheld XRF, is that it doesn't use radiation. It's using a laser source to do the testing with no radiation, so you don't have any of the safety concerns that you would with radiation. The main thing is you just got to protect your eyes. Usually some laser safety glasses are appropriate or recommended. There's also a lot less regulation and licensing because of that. Only about 5 or 6 states have regulations specifically regarding these handheld LIBS instruments. So there's a lot less headache when it comes to having a laser safety program and safety officers and training and all that stuff that comes with handheld XRF that you gotta worry about. Another major pro is the cost of ownership. Now, generally, the analyzers are about the same price when it comes to handheld XRF versus handheld LIBS. The difference is that handheld LIBS is a much sturdier piece of equipment generally, very rugged, built for the environments that you would see these handheld analyzers in. There's not a lot of fragile parts like XRF has X-ray tubes, detectors, coolers, all that stuff that can easily break, especially in the older instruments. When those break, they can cost around $7,000 to $10,000 sometimes, which is pretty expensive. Nothing like that's going to happen with the LIBS units. They're very rugged, and the laser itself is Probably the only thing you're gonna have to worry about replacing after 5 to 10 years, really, depending on your use. And the maximum cost of that's gonna be $3,500. So obviously much cheaper. There's not a lot of moving parts, and there's no windows to break in the front. So the only way, generally, that the laser is gonna go out is due to the end of its life cycle. One more well-known benefit of LIBS is its ability to do light elements, specifically in cases like separating aluminum alloys. It can see magnesium and silicon much better than handheld XRF, which allows you to separate some aluminum alloys, for example, 6061 versus 6063, which at times can be a 20 cents a pound difference in scrap. That can be a big deal when it comes to buying and selling large amounts of that material. And really the only way you can do that separation of those two is with a device like this. And LIBS is going to do it much faster and much more accurately. I'll talk a little bit about the cost of handheld LIBS. To purchase an analyzer, they're generally going to be between $20,000 and $40,000. The wide range there is there's a group of LIBS analyzers that can do carbon to some extent, and those are going to be closer to $40,000. Then there's another group of analyzers for LIBS that do not do carbon, and those are going to be your 20 to 30 range. Beyond the purchase price, the cost of maintenance and ownership is very minimal compared to the other two technologies of handheld XRF and OES. So you don't have to plan on spending a lot on either fixing or repairing or daily maintenance of the analyzer. Basically, the only kind of consumable you're using is swabs to clean the window of the analyzers on a regular basis. And that's about it. Over time, the cost of these analyzers is likely the lowest in the industry when you're comparing these three technologies. Some common mistakes people make with LIBS, and these mistakes have also led to the misconceptions about the performance and the viability of LIBS versus handheld XRF. Primarily, it comes down to sample preparation. See, with handheld XRF, it's very forgiving in that there can be some surface contamination. The sample preparation doesn't have to be perfect. You don't have to have perfect contact with the metal in order to get a result. With LIBS, it's very important to have a clean surface to get perfect contact, to be able to vaporize the metal and read the light coming back. So it's important to have a clean surface on the base metal, which means no coatings, no rust or corrosion, dirty surfaces can get in the way. Sample prep is very important when it comes to LIBS. So if you try to use it like your handheld XRF, you might not think it can perform as well because those surface contaminations have a bigger effect on LIBS. So really lack of training and understanding leads to these common mistakes with LIBS. The other common mistake is very similar in that you don't have perfect contact, maybe you're in a hard to reach place, it's a rounded sample, so you might not get as much light as you need, and that can lead to bad results or misleading results. So it really is important, and we can't stress enough the importance of the contact that you need with the metal surface. Now, this does not mean you cannot do small parts, which has been one of the misconceptions of LIBS. Some of the analyzers out there, as long as you're not moving the sample can provide the light feedback needed to determine the chemistry of the material. Some available brands for handheld LIBS. Unlike handheld XRF, there's less of a market leader like you see in Thermo Niton. So there's many brands available, such as SciAps. Thermo Niton just came out with a carbon analyzer, the Apollo. Hitachi has the Vulcan, and Bruker has a LIBS analyzer, and the Rigaku has the KT100S. So there's quite a few brands, not necessarily a market leader. And the interesting thing is Rigaku, currently the only brand that just has a handheld LIBS and not a handheld XRF. There was another brand out there, TSI, which decided to close their LIBS division at the end of 2019. So that means besides Rigaku, the other brands also have handheld XRF and sometimes OES as well. And I think that has led to some of the confusion around this newer technology. There has been less education out there for this new technology because the manufacturers are also selling their XRF and their OES. They may not necessarily want to talk about the shortcomings of the other technologies, which the handheld LIBS was specifically designed to speak to, like speed, cost of ownership, and safety. So overall, Some takeaways from this conversation today, this discussion. LIBS is the fastest and safest PMI technology available, but you do have to keep in mind training. It's not XRF, it's not Spark OES, it's its own technology, and if you train for it, then you can reap the benefits of the faster and safer technology. It's got the lowest cost of ownership with a lot less moving parts, much lower consistency of maintenance like you might see with Spark OES, and there's no expensive repairs. So thanks for listening to this episode of The Manufacturing Show. Again, I'm Chris Carolan with Metal Analysis Group. Please connect with me on LinkedIn to chat PMI or anything metals. I'm happy to answer any questions or provide recommendations. If you like this episode or have a quick question, join the discussion on Instagram at The Manufacturing Show. Thank you for tuning in and subscribing to The Manufacturing Show. And until next time, never stop testing your metal.